Thank you so much. First of all, I would like to thank the organizer of conference. Title of my lecture is on the temperature indices of fuzzy graphs and its application for QSPR analysis on autism drugs. This work is joint work with my colleague Mahsa Sadiqi and Jaber Ramzani. Medicinal chemists are facing serious challenges. Increasing costs, enormous amount of time taken to discover a new drug. Fierce competition amongst different drug companies. Some theoretical research have approached to applied mathematics to predict the result without any laboratory expenses to overcome the above challenge during the recent century. Graph theory in chemistry is an interdisciplinary field used to investigate molecular structure and establish connection between activities, properties, and various events. Chemical graph theory provides unique and creative tools for studying chemical structures, including topological indices that can be used for this purpose. The topological index is used as the descriptor to study the structure and some properties of a molecular graph and is expressed as a real number. The history of topological indices for molecular graphs to determine physico-chemical properties of alkanes. First, we refer to Wiener in 1947. The Zagreb indices have been introduced in 1972 to explain some properties of chemical compounds at molecular level mathematically. In 1975, the chemist Milan Randic proposed a topological index R under the name branching index, suitable for measuring the extent of branching of the carbon atom skeleton of saturated hydrocarbons. In this work, we introduced the concept of fuzzy temperature indices and rigorously compute them for fundamental fuzzy graph structure as well as their standard operators, including Cartesian product composition. Utilize a graph theoretical modeling approach. Fuzzy graphs are constructed for a selection of pharmaceutical compounds commonly prescribed for autism spectrum disorders, especially. The fuzzy temperature indices are then derived based on the underlying physicochemical description of these compounds. Now, we introduce some preliminary. Suppose G is a fuzzy graph, forms a non-implicit V and two mapping mu and sigma that satisfies the following inequality for all vertex X and V of vertex set V. Here, mu is symmetry and we use symbol XY instead pair X and Y. Mu star is support of mu and sigma star is support of sigma. A sequence of the membership of mu I v I plus 1 is positive for all I is named a path P of length n in the fuzzy graph G, and successive pair VIV index I plus 1 are considered as edge of the path. Now, let G be a fuzzy graph. Then we have a definition of cycle and fuzzy cycle. If the graph support of sigma and support of mu is a cycle, then G is named a cycle. And also, if there is no unique edge UV in support of mu such that we have this equality, and also the graph supports sigma and support of mu is a cycle, then G is named a fuzzy cycle. Also, a fuzzy graph G is called the complete fuzzy graph if we have this equality. Let G is a graph and V is a vertex of G. The set of vertices adjacent to V is called neighborhood of G. For all edge incidents at a vertex V in a fuzzy graph G, the sum of their membership values represented by this sample is called the degree of V. A small delta and capital delta present minimum and maximum degree of G, and also we have this symbol sigma index max, sigma index mean, mu index max, and mu mean. Let G be a graph for a vertex U. The temperature degree of U is defined as follows. Tu is equal to degree of U over n minus degree of U, where n is the number of vertices, du is degree of U. Using this temperature degree, the temperature indices were introduced by the following as U in table 1. There are many temperature topological indices of a graph, and also we can define for a fuzzy graph. Now suppose that G is a fuzzy graph. As a underlying graph, now we defined temperature index of a temperature index of a fuzzy graph. The temperature degree of a vertex U is defined as follows. As you see, is like the degree of a vertex for a crisp graph. But we know that degree of a vertex is different in fuzzy graph and in a crisp graph. According to definition 10, we can define temperature indices for a fuzzy graph, as you see in table 2. First temperature index, second temperature index, the modified second temperature index, and so on. Here we obtain some theorem about first temperature index. In fact, we obtain some bond for T1 of G. Let G be a fuzzy graph with MH and N vertices. Then we have this inequality, as you see. And also for a path, for a fuzzy path, we have this equality. T1 of P is less than or equal to this number.
Sir, Mr. Talebi?
Yes.
You have 2 minutes left. Please conclude your paper, please.
For the next page, continue. Can I
yes,
continue?
Prof. Yes, you can continue, Prof.
Application of fuzzified temperature index for chemical components.
آقای
Yes.
طالبی 2 دقیقه از زمان شما مونده، فقط سریع جمع‌بندیش کنید.
بله. Thank you very much. The 6 most prevalent autism drugs, including ziprasidone, aripiprazole, haloperidol, sertraline, risperidone, venlafaxine, are studied in this research. The molecular structure of these drugs are shown in figure 3. Furthermore, the values of 8 physicochemical factors, as you see, for all of these drugs are studied in table. In this study, six drugs commonly used in the treatment of autism were selected. Their molecular structure were falsified based on atomic masses and bond lengths. Temperature topographic indices were calculated for each molecule, as you see. In the following table, we obtain sigma, and also then we get temperature index for all drugs. Using SPSS software, the correlation between these indices and the physicochemical properties of the molecules were analyzed. And based on this correlation, linear...
Mr. Talebi, thank you very much.
Yes, finished. Please, 1 minute, just 1 minute, just 1 minute.
Okay.
Based on this correlation, linear regression models were developed for each drug. Conclusion, and also these reference that are used. Thank you so much for your attention. Thank you so much.
Thanks, Dr. Talebi, for your presentation. I'm so proud today to hear you, because you are. We have a common article on Matrazofic with Prof. Hussein Rashmallo. So,
yes.
Yes. So this good luck for your life.
Yes. I know, Professor. I know. Okay. I try to study your paper and your colleague, and I will try to use. I hope see you, and I will hope to do some other joint work. Thank you so much.